Now, y'all, let me say this. On the first two problems, they go back to our chart we made. So remember, the chart looks at the degree of the polynomial is either even or odd. And remember, the degree is the highest exponent. Then the lead coefficient can be a positive or negative. The lead coefficient is the number in front of that variable with the highest exponent. So we're going to have four choices on this. Even and positive, both ends are up. Even and negative, both ends will go down. Odd and positive, it'll go uphill left to right. Odd and negative, it'll go downhill left to right. All right, so I'm going to go switching this to Math Lab now for the actual questions, okay? So let me share Math Lab. All right, so there's number one. So we just want to know which would we choose, A, B, C, or D. So you got to look for the degree first. The highest exponent is a 6, so that is an even degree. Negative pi is negative. So when it was an even degree, negative lead coefficient, both ends of that will go down. So we would choose B on that one. Okay, so we're just looking at our chart. Now, number two will be the same thing. But notice the difference on number two. They got it out of order. We're still looking for where that highest exponent is. And y'all, the highest exponent here is a 7, which is odd. So I'm looking at the 0.2. That's positive. So when it was odd with a positive lead coefficient, would y'all go with A, B, C, or D? And y'all, if y'all remember my chart, that's on the bottom right side on that. And let's see what the chat's saying.
I think it's B.
Are y'all saying D is in dog?
I think they saying B.
B, okay, B, yeah, because it's positive. With an odd lead coefficient. Good job. All right, so now the next few I'm going to do on paper. So let's play with number 3 here. So number 3 wants us to find the zeros and multiplicity. All right, y'all, so they're giving us f of x equals parentheses x squared minus 16 to the 5th power. So the thing I'm going to show you right off the bat, that exponent 5 sitting outside those parentheses is going to be the multiplicity. Now, what we got to do is find the zeros. So we're going to set this factor equal to 0. And we're going to solve that. Now, since that's an x squared, we got to get 2 answers, okay? So, y'all, the easiest way I'm going to solve this is add 16 and do my square roots. So, x squared will equal a positive 16. And then we'll do square roots to both sides. Now, I'm taking the square root of a number. So, I'm going to bring out the plus or minus, okay? So, the square root of x squared, the exponent cancels the radical, leaving the x. And then that'll be a plus or minus, and y'all square root of 16 is 4. So for this answer, you'll pick the one that has plus or minus 4. Those are the 2 zeros, and each has a multiplicity of 5. So just remember, outside exponent multiplicity, zeros we find from the actual factors, okay? Now you could have factored this and got an x plus 4, x minus 4 equals 0, and then set both of those and got the two answers that way, okay? I just think square roots is a little quicker than the factoring. Now, y'all, same thing. Find the zeros and multiplicities. Now, this one I'll give our answers. They'll have sentences, and we're going to fill in the answer blanks, okay? So they're giving us f of x equals -8 times x minus 4 to the third times x plus 1 squared times x to the fourth. So remember that exponent 3, exponent 2, exponent 4 are all the multiplicities. We'll set each factor equal to 0, but the -8, since it don't have a variable with it, you're going to ignore that -8. You can even cross it out because it does not have a variable. Our zeros will come from the x's. So set each factor equal to 0. And remember, single x's, when you set them to equal to 0, that's automatically their answer. Okay? So now we solve these two. Add 4 to this one to move that. So I get an x equals 4. This one, I'm going to subtract 1. X equals -1. So I got my 3 zeros, 4, -1, and 0. So here's how they do the answer on this one. They'll have the 0, 4 has multiplicity blank. And then they'll say blank is a 0 of multiplicity 2 then they'll say the remaining 0 is blank. It has multiplicity blank. So we use what we got here to fill in the blanks. So the first question would be, the 0, 4 has a multiplicity of what? So y'all can light my chat up now if you want.
Is it 3?
3, perfect. Because that 4 came from that factor x minus 3, which had the exponent 3. So now they want to know blank is a 0 of multiplicity 2. All right, so now my chat's lighting up. -1, good job. Because -1 came from the factor that had the exponent 2. So y'all, that means the remaining 0 is blank, and it has a multiplicity blank. Well, there's only one left we ain't used. We've done the 4, we've done the -1. So let's see what my chat's saying. So 0 is the last 0 we had. And good job, it does have a multiplicity of 4. So that's the trick on those, okay? Remember, the multiplicities are just those exponents on the outside. It wasn't the exponent on the inside, the parentheses. That just tells me how many zeros I'm getting for that factor, okay? All right, y'all, so let's move on to number 5. Now, number 5 is going to be our fun one, and let's see if y'all remember. So I'm going to find the zeros and multiplicities. But if you noticed, everything we've been doing so far pretty much has been factored. But look at this one. They're giving us f of x equals x to the third minus 7x squared minus the x plus 7. So this, and we physically had to factor this 4-term polynomial. So y'all remember, I did this by grouping. I grouped those first two together, and then I grouped the last two together. And what I want you to do for me, I want y'all to tell me what the greatest common factor is between an x third and a 7x squared. Because remember, we're now going to factor out greatest common factors. So what's the most they got in common?
X squared.
X squared. Good job. And if we factor out the x squared, that'll leave an x minus our 7. Now, the second GCF member always had the same sign as that third term. Well, that x is negative, so automatically your second GCF is negative no matter what. All right, so how about this one? What's the greatest common factor you can pull out of an x and a 7? And I think there's only one thing they got in common. All right, let's see my chat going. A1, good job. Y'all, the second GCF, you at least have to factor out a 1 on that one, okay? Now, good job, y'all. Now, if you remember, the parentheses better match up at this point when we're done. Well, if you had a negative x, divide out a negative 1, that's going to make the x positive. And if you had a positive 7, divide by the negative 1, that's going to make that a negative 7. Notice, my two parentheses got to match up. All right, y'all, at that point, I made another set of parentheses. Can you tell me what's going to go into each of these parentheses now? All right, y'all, think about it. On this one, I did the stuff on the outside in one parentheses. So the stuff on the outside is the x squared minus 1. So let me see my chat. So good job, Viddy. That's good. X squared minus 1, and then the stuff that was inside made up the other one. All right, y'all. So we are now factored. So I don't have exponents on the outside of these parentheses. So remember, we got to treat both of those parentheses like they got a 1 out there, okay? Because it will ask us for our multiplicity in a second. So each of these are the factors. So now we put our multiplicity of 1. And to get to zeros, we're going to set everybody inside the parentheses equal to 0. Now remember, that's the x to the third. We got to get 3 zeros, okay? So y'all going to square root this again. But remember, if you like factoring, you can factor that. Okay, so now x squared equals 1. I'm going to square root both sides. This will be a plus or minus square root of 1. So that x equals a plus or minus 1. So there's 2 of my zeros. Now I'm going to get the third one by what? Adding 7 to my other equation. And I'm going to get an x equals a positive 7. So they'll have a blank. The zeros are blank. Each zero has multiplicity blank. So you can use the plus or minus 1, or you can go 1, -1, and then 7. And then we said each zero, remember, there wasn't no exponents out here, so we made each of these a 1. Hey, y'all, so remember, the trick is matching them parentheses up on that problem, okay? All right, so then we got a true or false. So let's see what y'all remember about these multiplicities. If P of X equals X minus 9 squared times X plus 5 to the third, then the graph crosses the x-axis at the point 9, 0. So we just want to know if that's true or false. Now, here's the thing you got to remember on this. If it's an even degree, even multiplicity, guess what? It is tangent. Even exponents are tangent. If it was an odd degree or an odd multiplicity, then it crosses the x-axis. But look here. So we got to figure out which of these two factors did the 9, 0 come from? Well, the 9, 0 came from the first factor, the x minus 9 squared. So since that 9 came from this x minus 9 squared, I'm looking at its multiplicity, which is a 2. 2 is an even number. That means that it would be tangent to the x-axis. Well, look here. They said it crosses. So since it's actually tangent and it don't cross, this would be false. Now, if they'd have gave me the point -5, 0, -5, 0 would have came from this factor, which had an odd exponent. That one would have made it true because of the odd exponent, okay? But they were looking at this factor. Now, what we got to say is it's false because the exponent 2 is even, thus it is tangent. Okay, so you got to give it the right answer. Why? Okay, because 2 was even, and actually evens are tangent, okay? All right, this one's not too bad. For the function, determine the maximum number of real zeros, x-intercepts, and turning points. Now, let me see what they're giving us. They're giving us f of x equals a -3x minus x to the fourth. So what we want our maximum real zeros. Then we'll get our maximum x-intercepts. Then our maximum turning points. So, any of y'all can tell me what is the maximum real zeros from this polynomial? Well, it's been a while since y'all done these ones, right? All right, chat. I'm not seeing my chat lighting up either. Oh, so I'm stumping y'all on one of my give me questions. So y'all remember this. The maximum real zeros is equal to the degree of that polynomial. So my question is, what's the degree of that polynomial?
Wouldn't it be 4?
It's 4, definitely. So remember, the degree is the highest exponent, which is our 4. So if you got 4 real zeros, how many x-intercepts will I have? Because zeros and x-intercepts are the same thing, ain't they? So that's going to be 4 again. Good job. Now, the one that's going to be different is what's the maximum turning points?
3.
3, good job. So equals the degree, equals the degree, equals the degree minus 1. Okay, so let's write that. Degree, degree, degree minus 1. Okay, so find the highest exponent, write that twice, subtract 1 and write that and be done, okay? All right, y'all, let's see what they got on, I'm going to Math Lab. 8 and 9 are graphs. So let me take us to Math Lab and go to number 8. Whoops.
Mr. Eugene, which chapter is this? I came in late.
Oh, this is our chapter 3
this is the test. Oh,
So we're doing our review for the chapter 3. And then next week we'll start chapter 4 material or test 4 material. So these problems right now are coming out of like the 7-1, 7-2, and then getting into zero stuff, the 8-3, 8-4s, and all those. Now look at this. We're going to graph this, but I want y'all to see this. Look at these graphs. I'm going to zoom one up. They go from -10 on the x's, but from -100 to 100 on the y values. So I'm going to show you how to set the window to graph these. So y'all, let me write this down. I got a h of x equals x times x minus 3 times x plus 5 times x minus 5. Now it goes from -10 to 10 on the x's and -100 to 100 on the y's. Because if you don't change the windows on these, you're not going to get one of these 4 pictures that looks nice, okay? All righty, so I'm going to go to the calculator now. So let me put in the function into y equals first. So I had an x, parentheses, x minus 3, parentheses, x plus 5. And then my last parentheses had a x minus 5. And then close parentheses. So I got the function in. Now, you see the second button by the y equals says window. I'm going to hit window. Now my x's went from -10 to 10, so I'm going to keep that. I'm going to go down here to the y minimum was -100. So I'm going to put a -100 there. And then that y max was a +100. So now that we got our window set, when we hit graph, we will get exactly one of their 4 pictures. So y'all, here we go. We're going to hit graph. So it's almost got a W shape to it. And it's going uphill on both of the ends. So yeah, it's almost like a W shape. So we would go back to Math Lab. And y'all, it looks like it's going to be A. See, A's got the W shape. B is sort of like an M. C has too many lines going everywhere, and then D was just going uphill. So the one I would pick would be my A, and then I would go to the next one. All right, same thing here. So let me write that down. That is 10x to the third minus 4x squared minus 90x plus 36. Now, I don't know if y'all can tell, but look at B and C. They're really close. So I'm going to zoom B and C in just a little bit. B is going right through the origin where the X and Y cross. C is above it a little bit. So let's go graph this. Now look at this one. This one goes from -5 to 5 on the X's and -250 to +250 on the Y's. So once we change our window to match that, we will be able to tell which one this is. So I'm going to go to Y equals and clear that. So I had 10x to the third All right, let me arrow down now. Minus 4x squared minus 90x plus 36. Now the window went from -5 to 5 on the x's. Then the y went from -250 to 250. So let me put that in for y min, and y max was 250. All right, I got my window set, got my function in, so I'm going to hit graph. Oh, so y'all, it was the one that went uphill left to right, but look at it. It's above the origin. It does not cross in the origin. So y'all got to be careful on this one, because although B has the right shape, it is going right through the origin there, okay? We need C, which is the one above the origin, okay? Now, every time I've done this, it's been the one that's above the origin, so just be careful on that. All right, y'all, so let me see. Let me get my paper turned over here. All right, let me see the chat. What was the answer on 8? On 8, I went with the one that sort of looked like a W, which would have been A. And really that's why I like that calculator. It's going to graph those exactly what they look like if you change those windows, okay? All right, y'all, number 10, check this one out. Let me see if y'all remember this stuff. This one says, using synthetic division, determine whether the numbers are zeros. Okay, so they want to know if these numbers are zeros. They're giving me a -2, 1, and then a semicolon, and my function is h of x equals x to the fourth plus 2x to the third plus 2x squared minus 4x minus 1. So two numbers means we're doing synthetic division twice. So we're going to start with the -2. So let's see our coefficients, x4, x3, x2, x in our number. Everything's here. So we write our coefficients, which will be a 1, 2, 2, -4, and -1. All right, y'all, so I got my coefficients written out. Now, I'm going to draw my line with my box under it. So, here's my question. If -2 is a 0 of this polynomial, what does the remainder have to be? And y'all can chat that. Oh, I'm going to get y'all. If it's a 0, what better be that remainder? All right, let's see. Read definitely. That's got to be a 0 for me to say yes. Any other number, I'm putting a no, okay? Remember, that's the property of a 0 is that they have a 0 remainder. All right, y'all. Synthetic division. First step.
You're gonna bring down that 1.
Okay, I'm gonna bring down that 1. All right, what you doing now?
What you do? Negative? Is it? Hold on a minute. No, I might be right. -2 times 1.
Oh, so you say multiply that?
Yeah.
So 1 times -2 is -2. All right, now what y'all doing to those?
You're gonna subtract.
So that's a big 0. And guess what? Now we're just going to repeat, right? 0 times that is 0. 2 minus 0 or 2 plus 0 is 2. 2 times -2 is -4. Uh-oh, y'all, but -4 and -4 give me -8. So I don't think I'm getting a 0 here because -8 and -2 is 16. And y'all, that gives me a remainder of 15. So that's definitely a no for the -2. So use the same numbers for 1. So I got a 1, 2, 2, -4, -1. All right, y'all, so here we go. Bring the 1 down. 1 times 1 is 1. 2 plus 1 is 3. 3 times 1 is 3. 2 plus 3 is 5. 5 times 1 is 5. 5 and -4 is 1. Oh, look at that. 1 times 1 is 1. And -1 plus 1 is a 0. So 1, since I had a remainder of 0, would be a yes on that, okay? So y'all, that's all you're doing to that. So let's see what y'all put on this one. This one will be on y'all because this one says, suppose a polynomial degree 4 has the following zeros. Then they say, find the other zeros. So on our answer, we're just finding the other zeros. So our answer blank will say the other zeros are blank. Now, they're giving me a -I and 4 minus the square root of 13. They're giving you 2 of the zeros. What I need are the other 2. So what y'all think on that? Uh-oh, y'all forgot. Remember my conjugate pairs on these. If negative I is a 0, then what else has to be a 0?
I.
I, there you go. If 4 minus square root of 13 is a 0, what else has to be a 0?
4 plus square root 13.
4 plus square root of 13. Notice all we did was change the sign on the radical. Good job, y'all. So remember, number 11, they'll give you 2. You got to find the other 2, okay? Now, why did we have to know this? So that we could do number 12. Find a polynomial of lowest degree. So since they're saying lowest degree, they're not letting us know how many zeros we're supposed to have, okay? So find the polynomial lowest degrees with zeros of square root of 5 and 5i as sum of its zeros. So they gave me 2, but that ain't all of them. They said that was some of the zeros. So remember, when we started finding polynomial, we took all the zeros and set them equal to x, right? So look here. The first 0, x equals square root of 5. But if square root of 5 is a 0, what else must be a 0? Well, y'all better be saying a negative square root of 5, right? Remember, y'all just told me up here, they got to have their conjugates. So if they give you a square root of 5, negative square root of 5 is a 0. Look here, they're giving me a 5i. If 5i is a 0, well, what else must be a 0?
Negative 5i.
A negative 5i. So on number 12, they will give you 2, but you better get the other 2, okay? Now, this is where we started doing, we subtract and add to get to zeros, and then we're going to put them in parentheses. Then we'll start foiling stuff, okay? So let's get zeros on the right side by adding and subtracting. All right, so there's my radicals. So let me do that with the i's now. Subtract those. And then add that last one. So remember, once I got my zeros on the right side, I put everything in parentheses. And I said, oh, that equals 0. Okay, so then I got to start foiling stuff. Well, I would foil these 2 together, and I would foil these 2 together. These are all conjugate pairs. Now, since these are conjugate pairs, I'm going to do my shortcut foiling, okay? I'm not foiling all this out in 4 steps because the middle's always canceled out. So to shortcut foil this, then I'm going to make me 2 sets of parentheses. So I'm going to foil the first one. You multiply the x times x. That's going to give us x squared. Then you do the negative square root of 5 times the positive square root of 5. So that's going to be a negative square root. 5 times 5 is 25. Now that has one more step in a second, right? In a second, we're going to take the square root of that 25. Now let's start fooling this one. Conjugate pairs, so we're going to shortcut this. X times x is x squared. This negative 5i times 5i is a negative 25i squared. So that's technically still equal to a 0. Well, two things I want to ask y'all. First of all, this is going to be x squared, square root of 25.
Five.
Okay. I'm about to say, we did them in Arkansas growing up, right? Now, here's the thing to remember. In the long run, square root of 5 times square root of 5 gave me a 5, okay? Now, on this one, I'm going to bring down the x squared. Who remembers what I squared equals? -1. Good job. Remember, I squared equals -1. So if you replace that I squared with a -1 here, negative 25 times -1, we'll make that a positive 25. So notice, the radicals always end up negative. The imaginary numbers always end up positive, okay? All right, now, I will foil this the long way because these are not conjugate pairs. That's got a -5. That's got a plus 25. So we got to foil this one all the way out. So here we go. X squared times x squared is a x to the 4th. X squared times 25 is a positive 25x squared. So now let's start distributing the -5 times x squared is a -5x squared. And then finally, the -5 times 25 is a -125. So the question, can you do anything else to that? Or is that my final answer? Because they're going to have a big answer blank.
Um,
I'm hoping y'all see one thing y'all can do.
Like
Well,
term.
wouldn't it be
Like
20
terms, right?
at
So yeah, those like terms is going to give me what y'all said, 20x squared, okay? So my final answer will be the x4 plus 20x squared minus the 125. So when we write it as the function, we don't have to put the 0 stuff, okay? All right, y'all. So yeah, that's all. That's a lot of foiling there, but that's one of the only ones where we had to do all the foiling. Just remember, if a square root of 5 and a 5i are zeros, then their conjugate pairs also must be zeros, okay? All right, y'all, look here, 13. 13 says the polynomial has the given 0. Find the other zeros. All right, so let's see what they're giving me. My function f of x will equal x to the 3rd plus 5x squared minus 3x minus 15. And then they got the semicolon, and the 0 they're giving me is the -5. Now, we won't write -5 in our answer because they just want us to find the other zeros, not the one they're giving us. So on this one, since that's an x to the third, we're going to end up with 3 zeros when we're done. One will be the -5 they're giving us. So what we got to do, synthetic division, and divide out that -5 first. Then the 3 numbers that are left, we can solve using one of our quadratic. We can do the factoring, we can do the quadratic formula, or we can do the square root stuff, okay? But we got to get it down to 3 numbers in the quotient before we can do that. So it's going to take one step of dividing out that -5. Now let's see, x3, x2, x number, nothing's missing. So I got a 1, 5, -3, and our -15. So what's the remainder got to be if they're giving me -5 as a 0, y'all? That way I can make sure I'm doing my synthetic division right. So what remainder do we need to get? All right, Reed, that's on you.
0.
0, there you go. So we got to get a 0 remainder. If we don't, then we didn't do this part right, okay? All right, y'all, here we go. Bring down to 1. 1 times -5 is -5. 5 minus 5 is 0. 0 times -5 is 0. -3 plus 0 is -3. And y'all look here. -3 times -5 is a +15, which gave me a 0 remainder. Well, we knew that because they told us that was a 0. Now remember, these are the coefficients of the new polynomial, 1 degree less than the original. So that means that is 1x squared. There's 0 x's in the middle, and then we got our -3. So to solve for the last 2 zeros, we're going to set that equal to 0 and solve it. So this one don't factor, so I'm going to add 3 and do my square roots, okay? So add 3 to both sides. X squared equals 3. And then let's do our square root. So that'll be a plus or minus square root of 3. So y'all, that cancels, giving me my x is a plus or minus. Oh, and y'all, guess what? We can't do nothing with that square root of 3. It's not a perfect square. So that's going to stay square root of 3. So this one, the answer blank will say the other zeros are blank. Do not put in the -5. Put in your square root of 3 and your negative square root of 3. And it'll probably let you do the plus or minus like I got this one, okay? All righty, so one more doing the 0 stuff. But the thing is, on this one, on 14, they're not giving me none of the zeros. So watch how I have to find them on it, okay? So this one says, find the rational zeros, then the other zeros. So y'all, the other zeros, that's going to be the radical stuff or the I stuff. If it's a radical or an I, that's the other zeros. Everything else will be rational. So find the other zeros, then factor into linear factors. And that's where we put them in parentheses, okay? Now, they're giving us f of x equals 3x to the third plus 7x squared plus 147x plus 343. Now notice nothing's missing, but the way I'm going to get the first zero on this one, so let me tell you a clue or a hint. I'm going to get the first zero by graphing. Once I got my first zero, then I can divide it out, and then I can do the quadratic stuff to get the last two, okay? So let's go graph this, and I'm going to have to show you a trick on this one, okay? Because this one ends up with a fraction, but let me show you how to get that. So I'm going to go share this and go to my calculator. I'm going to go to y equals and clear everything out. Now, let me show you what I'm going to do first. I'm going to reset it back to a 10 by 10 by doing zoom and number 6. That'll put me back on a 10 by 10 graph, okay? Just to start out with. Now, y equals, I had a 3x to the third. All right, let me arrow down. Plus 7x squared. Plus 147x plus 343. So I got my function in there. So I'm going to graph it because I need to find where is it crossing the x-axis at. So y'all watch this. When I hit graph, oh, y'all look at that. I can see where it crosses, but it's crossing in between the -2 and the -3. So it's not right on -2 or -3. So look here, when you go to the table between -2 and -3 up here, there's -3, there's -2. I'm not getting the y value of 0 because it's not showing me the fractions. So watch how I change that. Y'all see above window it says blue table set. I'm going to hit the blue second button and the window button. Now my table is going to start at -4. But down here where the triangle table is, that means how much do I want my table to change. Now, my very first number, I had a 3x to the third. Since I had a 3 in the front, I need to make this 1 divided by 3. I want it to change by thirds since I had a 3 in the front. If you have a 2 in front of your x3, you're going to do it by halves. If you got a 5, you're going to do it by 1/5. Now watch what happens when I go to my table. It's going to go by thirds and break everything up by thirds. Well, guess what? You see a 0 now for my y value. Let me go to the y and let me arrow down. And there's my 0. And it's happening at a x equals -2.3333. And that 3 is going on forever, okay? But I'm going to show you how to change that into a fraction. So I know it's -2.333. So I'm going to punch that in. -2 point. And you got to have enough 3's for it to change it for you. So that should be enough. I'm going to hit math and enter twice and turn that into a fraction. I get a -7/3. That's the first 0 I'm going to check now, okay? So y'all, remember, graph it, see where it's coming across at. Then set that table to match that. Now, if you want the table to go back to normal, go back to second window to get the table, and go down here and put that as a 1 again. Now, when I go back to my table, everything's going by 1s, okay? But you gotta change it to get that fraction. So negative 7/3 is my first number I'm going to try. All right, let me write my coefficients. 3, 7, 147, and 343. If I'm correct, what will my remainder be? Okay, it's going to be a 0. Good job, Taylor. So we got to get a 0 there, y'all. So watch this. Bring the 3 down. So negative 7/3 times 3. We all the 3's cancel, so that gives me a negative 7. 7 minus 7 is 0. 0 times negative 7/3 is 0. 147 and 0 give me 147. So now I'm multiplying that negative 7/3 times 147. And you can punch that in on your calculator, but that will give me a negative 343. So 343 minus 343 gave me a 0 remainder. So that definitely is a rational 0 because it crosses the x-axis. So I got to get the last 2. So remember, that was the x third. This starts as the x squared. So I got 3x squared, 0 x's plus 147. I'm going to set that equal to 0 and solve it. So I'm going to do the square root stuff. So I'm going to subtract 147 first. So y'all, that gives me my 3x squared. Those cancel. That's going to equal negative 147. All right. Now, before I square root it, I'm going to divide by 3 because you want the square root to be just the x squared, okay? All right, so that cancels. I got 1x squared now. So y'all, that's a negative, let's see, 147 divided by 3, that's a negative 49. Now the x squared is ready to have the square root done. So I'll do a plus or minus square root of negative 49. So y'all, this gives me an x for sure. And this will give me a plus or minus. So the question for y'all, what is the square root of that negative 49?
Not imaginary.
Oh, it's going to be imaginary. So what's the square root of 49?
7.
Uh-huh. And then since it's imaginary, you're going to put a I behind it. So good job, Faith, because remember, square roots of negative numbers will give me imaginary answers. So these are the other zeros. So in the answer blank, it'll say rational 0 equals negative 7/3. The other zeros are, what do we get? 7i and a negative 7i. So you got to remember to always use the plus or minus on square roots to get both answers. So those are the 3 zeros. Now, the linear factors, they'll have the f of x equals, and then the answer blank here. All we're doing is changing the signs of all these, putting them in parentheses. So since that's minus 7/3, this will be x plus 7/3. Since that's plus 7i, this will be x minus 7i. Since that's a negative 7i, this will be x plus 7i. Now, y'all, there's only one more thing we got to do to this answer. And this is a weird way that MathLab does it. But what they do, since this fraction has a 3 on the bottom, we need to put a 3 in front of those parentheses. So whatever number you get on bottom of your fraction, if you got thirds, put a 3 in the front. If you got a 2, you'll put the 2 in the front. Whatever's on bottom of the fraction, okay? And that's just a weird thing Math Lab does on those ones. Probably more than I would do on it, but y'all know. All right, y'all. So let's see, 13 and 14. So what? Oh, we're starting our domain stuff next. So the domain stuff started in 5-1. So 15, find the domain. They're giving me f of x equals x to the third minus x squared plus a x plus 1 all over x squared plus 7x plus 6. Now we'll say this one. This problem, I got to write the answer in set builder notation and interval notation. So y'all, if you was going to find the domain of this, what would you do? How do we find our domain?
Do we set the bottom equal to 0?
I set that bottom equal to 0 because all I'm worried about is a 0 in my fraction, right? All right, y'all, so let's set this bottom equal to 0. And these ones always factor. Now you could do the quad formula, but that's a lot of stuff to do to this. X squared is an x and an x. My last number's positive, so both of these will be positive like the middle. And all y'all got to do is find me factors of 6 that add to give us 7.
6 and 1.
6 and 1. All right, now set both of them equal to 0 and we'll get our answers. All right, y'all, so it looks like what, a -6 over here. And then what, a -1 on that one. Now, here's where you got to watch out. They have x such that x is a real number. And x cannot equal blank. And x cannot equal blank. But y'all, here's the trick on this answer. The numbers have to be in ascending order. So you got to figure out which one of these is the smallest and put it first, and then the largest one goes second. So what would y'all put in the first blank? Which of these numbers is the smallest?
-6.
-6. And then we'll put our -1 there. Now, interval notation, we started at -infinity. And we got to kick out these two numbers. So -6 comes first. So we're going to union around that -6. And then we're going until we hit -1. We're going to union around that -1. And then we head off towards infinity. I think that's why they wanted them in the right order here, so that we would put them in the right order down here too, okay? All right, y'all, guess what? The next one, find the domain. So this one came from 5-1. This next one came from 8-5 section. And it has a 2 on top over x squared plus 3x minus 28. Well, how are you finding the domain of this problem? So what's our first step?
Are you also gonna set it to 0?
I'm going to set it equal to 0. Okay, I guess that wasn't a trick question enough, huh? Same thing we did here, right? So let's do that. So this one will factor also. But y'all look here. The x squared is still an x and an x. But your last number is negative. So that means one of these will be positive. One of these will be negative. Now, when the last one's positive, your factor's added to get to the middle. When they're negative like this at the end, I need factors of 28 that'll subtract and give me a 3. So y'all multiply whatever can get a 28, but make sure they subtract and get me a 3.
7 and 4.
7 and 4. There you go. So who would we make positive?
The larger number.
Okay, so 7 will be positive. Y'all remember, larger number always has a sign as the middle. All right, so we're factored. Now we're just going to set these equal to 0. So I'm hoping you are learning my tricks on factoring, because factoring's not bad if you learn those sign tricks, okay? All right, y'all, so this one's going to give me a -7, and this one will give me a +4. So my domain, we just had to do this one in interval notation. So it's going to start at -infinity until I hit my first number, which will be that -7. Union around that -7 till we hit our 4. Then we'll union around that 4 till we hit our positive infinity. All right, so 17 will be another one in Math Lab that I got to pull up the question for so that we can pick the graph. So let me share my number 17 on Math Lab. All right, y'all, hang on a second. I timed out, I guess. So let me go back into this thing and get my problem for us. All right, we're doing test review. And I said, well, it was on 17, was it?
Yeah, 17.
All right, so I just want to write this down real quick. So 17, r of x equals 9 over x squared minus 100. So look here. They want the vertical asymptotes. So we're going to find the vertical asymptotes. On this one, it says the oblique. You're going to put B on that one. We did not do oblique asymptotes, okay? So we'll put B on that one. And then when we graph it, look at that. It's going from -20 to 20 on the x's, and then -2 to +2 on the y values, okay? So I'm going to work this, and we'll get our asymptotes first, and then we'll look at what that graph will look like.
Okay.
All right, y'all. So remember, no obliques on these. No obliques. So that'll always be B for that one. So vertical asymptotes occur where the graph is undefined. So to find where it's undefined, what am I going to do to find my vertical asymptotes? Well, y'all, we're going to do the same thing we do for the domain, because those are numbers that make it undefined. So we set the bottom equal to 0. So, because remember, these happen where they're undefined. Well, these are the numbers where they're undefined. So the domain and the vertical asymptotes are pretty dang close together, okay? I'm just going to add 100 and do the square roots to this. So x squared will equal 100. And then let's do our square roots. So that'll be a plus or minus square root of 100. So y'all, exponent cancels radical. So the x, and this will be a plus or minus square root of 100 is a 10. Now, you got to write it as an equation in MATLAB. So let me go show you how you would write in your vertical real quick. See, they don't have the x's there, and it says right here, type an equation. So you're going to do x equals 10 comma x equals negative 10. Okay. Now there's no oblique, so now we're going to go get our horizontal asymptote. So let me go back to the page. So the horizontal asymptote, I compared the degree on top to the degree on the bottom. So my first question, what's the degree of the top of this fraction? What did we say the degree was when there wasn't a variable?
1.
0.
0, there you go. Now, if it had a variable, then it would be a 1 for the x, okay? All right, down here, the degree is what on the bottom?
2.
2. So the degree on the bottom equals a 2. So it looks like the bottom is bigger than the top. So the bottom degree greater than the top degree. So I had 3 cases. What did we say would be the horizontal asymptote if the bottom was bigger than the top? That's going to be y equals what? Uh-oh, got y'all on that one. How about if the bottom's bigger, remember, the numbers are trying to get closer and closer to 0. Now, if the top's bigger than the bottom, there's no horizontal asymptote. If they were equal, then I look at the numbers in the front, okay? But the bottom's bigger, it's going to be y equals 0, so we're going to go put that in. And we got to type an equation on that one. So click that and put in a y equals 0. Now let's go graph that. So let me go share my calculator. I'm going to go to y equals, clear that out. Now I want mine to look like a fraction, so I'm going to hit the green alpha button, the y equals, and enter. That puts up those fraction boxes, okay? Now on top I had a 9. On bottom I had x squared minus 100. Now, I'm going to set my window to match what they had. I had negative 20 for the left x. I had positive 20 for the maximum x. And then down here on my y minimum, I was doing negative 2. And then the y maximum was a positive 2. So now when we graph it, we can pick our picture. Y'all, there you go. Notice you got a vertical asymptote on that left side at that negative 10. You got one on the right side at the positive 10. It's not crossing those two imaginary lines. So knowing that, let's pick our picture. Oh, let me look at it one more time. So my U is going upside down in the middle. Okay. Now, y'all, so mine was upside down, my U, so mine looked like D. Okay, so on that one, pick your graph and be done. All right, y'all, so let's see. Let me go back to the page now. All right, so 18 says determine the horizontal asymptote. All right, y'all, they're giving us f of x equals x squared minus 4 on the top over 5x4 plus 4 on the bottom. So do y'all want to guess and tell me what is my horizontal asymptote going to equal? Do I have one? And if I do, what's the equation? If I don't, then just tell me, hey, there ain't one. All right, my chat's lighting up. Y equals 0, right? Because y'all, degree 4 in the bottom, degree 2 on the top. 4 is bigger than 2. So Reed, you and Nancy looking good, okay? So this is bottom greater than the top. So once again, it is definitely y equals 0, okay? All right, y'all, then we started getting into the inequality stuff that we did Tuesday, okay? So there's 2 problems doing that. So let's look at number 19. 19, they got solve the inequality. Now this one's already factored. X minus 2 times x plus 3 less than 0. So y'all remember, these are the ones where I solved them, made up a number line, and I tested my 0. You can test any number, but 0 is probably the easiest one to test, okay? So since 19 is already factored, set both of these equal to 0 and get me those 2 numbers. So here, add 2. So x equals a 2. Here we'll subtract 3. And x equals a negative 3. So I set me up a number line off them 2 numbers. So let's see, negative 3's over here and 2's right there. Now, I pick my test point and I always use 0. So I'm going to test the 0 that's in between negative 3 and 2 by putting a 0 in for both of these x's and seeing if this is less than 0. So that'll give me 0 minus 2 times 0 plus 3 has to be less than 0. Well, this equals negative 2. This one equals positive 3. So is negative 2 times 3 is what, a negative 6. Is that true or false?
True.
Okay, that's definitely true. So let me see what my chat's saying. They takes a while to actually write all that, don't it? So good job, Nancy. That is definitely true. So since it was true, since it's true, I shaded that section where that 0 was located. And that's the only section that we're going to shade. Now, if that would have been false, I would have shaded this section and that section. So my interval is going from negative 3 to 2. So y'all, here's the main question on this problem. Would y'all use parentheses or brackets around these numbers? And it all depends on that less than right there. All right, chat's lighting up. Oh, I got y'all, didn't I? Oh, those look like brackets. So now, there you go. We want parentheses. So it's got to be parentheses, y'all, on those numbers. Remember, Parentheses if it's less than or greater than, brackets if you got the equal. Okay. But all of these have been less than that I've seen so far, so they all had parentheses, okay? All right, y'all, then there was one. So let's see our number 20. Same thing, solve this inequality. X squared plus 8 less than 2x. So what do we think's the first move I got to do to that problem? All right, let's see my chat. Let me see what they got going on. Okay, I'm going to minus the 2x. Nancy, don't divide that yet. Remember, what we need is a 0 over here. So since we need a 0 over there, minus that 2x. That way we got everything on one side equal to our 0, okay? So then I'll put them in order. X squared minus my 2x plus my 8 has to be less than 0. Now, this one they already factored, so we got to try to factor this one now. So when I factor it, I'm actually going to set it equal to 0 to get all my answers, okay? So here's the x and an x. This one's positive, so both factors will be negative like the middle. So see, the plus means like signs, like the middle. All right, y'all, so now find me factors of 8 that add to get 2.
6 and 2.
Oh, 6 times 2 is 12. We want factors of 8.
Mm,
So remember, factors of 8 would be 1 times 8. Oh, and the only other way I think is what? 2 times 4.
yeah.
But none of those are going to add to get a 2, are they?
No.
Because remember, that ain't minus. If it was minus, I would pick 4 and 2 because they would
Right.
subtract. But since that's adding, they got to add to get 2. So none of the factors work. So
No.
this one does not factor.
Okay.
I don't think I've seen none of the number 20s that actually factor. This one always has the same answer. So if it does not factor, what was my answer? What do we call it when we don't have an answer?
Undefined.
Well, no, not undefined. That's when you're dividing by them zeros. No solution.
No
Good
solution,
job.
yeah.
No solution. Remember, this is a no solution. But do y'all remember how MathLab had y'all put that in?
It's
didn't
the
write no
zero
solution.
slash two.
Oh, what? I think you said it. What was it?
It's the 0 with the slash through it.
Yeah, right there, y'all. Bam, bam. Pick that on number 20 for your no solution, and then submit this and be done. Y'all, this test ain't bad. There's a few, like I said, the number 14 where you had to do the little trick with the fraction when you use a table. And then set them windows like they're setting them graphs, and you'll be good to go. Oh, so show the work on this one. So y'all show work. And I picked some mellow ones on this. 3, 5, 10, and 12. Yeah, so we always pick some of these because the Higher Education Commission and all that thinks that y'all need to show work. We do this so that y'all don't have to go on campus and test, okay? Because that'd be too hard trying to find times when everybody can go test on campus. So yeah. So 3, 5, 10, and 11, 12, email them, text them, pictures, anything will work, okay? Now remember, this test is due Tuesday night. So that would be, let's see, 11, 12, 14. The 16th, I guess that is, I said. For y'all, okay? So, now I'm sending a bonus question, but if you want to write it down right here, here's my bonus question for this test. So write this down because I'll
A
email this.
bonus.
Huh?
A bonus. Oh, you mean like the one you email us?
Yeah. Yeah.
Oh, okay.
So you'll send me the answer to this and I'll add 5 points to your test if it's correct. And it's really easy, y'all. Watch this. If a polynomial has zeros of -7i, 2, and -5. Oh, hold on. If a polynomial degree 4, so it's a degree 4. If a polynomial degree 4 has zeros of -7i, 2, and -5, what is the other zero? Send me that answer in an email or text. And when you get done with your test, that's 5 points. And hopefully this is easy for y'all now, okay? But don't tell them, just play with that, okay?
Okay.
Because y'all, this is gonna put some of y'all doing the bonuses got like 100 and something average in my class, you know, so that gives you a lot more play when you hit that final exam, okay? Alrighty, so test due Tuesday. We'll start 9.3. Do the bonus, send me that for those 5 points. Other than that, good luck. Oh, the final exam, we'll do that. It'll be due by May 10th. I think May 10th is our last Friday. So it'll be due then, and we'll review that week, okay? I plan on doing our review I think that Tuesday is when I'm going to review for the final. And y'all be happy. The final is 25 multiple choice questions.
Okay.
That's better than y'all